This instructional video will show you how to determine a value for an equilibrium constant given a set of data for concentrations of species in a reaction that are already at equilibrium. So here we have a balanced reaction and we have the correct equilibrium constant expression. In addition, we have 4 experimental trials, each of which has the data for the concentration of the NO2 and N2O4 when it's at equilibrium. In order to calculate each individual Kc value, I'll have to substitute these values in. And so we have 5.95 times 10 to the negative 1 divided by the square of our NO2 concentration, 5.2 times 10 to the minus 2. So with a little bit of calculator magic, I already know in advance that the answer is 220.0. And we'll do the same thing for all of the rest of these. 0.127 divided by 2.4 times 10 to the negative 2 squared. And this one ends up giving me 220.5. Here we'll have 1.02 divided by 6.8 times 10 to the negative 2 all squared. And this value comes out as 220.6. Finally, 2.24 divided by 0.101 squared, and the value here comes out to 219.6. Now, based on this experimental data for concentrations at equilibrium, we've calculated values for the equilibrium constant for these 4 trials, and the only thing left to do is take an average. So add these up, divide by 4, and we find that the average Kc is equal to 220.2. And this shows us how we can take actual data for concentrations at equilibrium using what we know from the balanced reaction and the equilibrium constant expression to determine an average value for the equilibrium constant itself.